Good afternoon, everyone. A warm welcome to everyone. Thank you for joining our next session for this week. This is our first session for which will be the session 12, focusing on auto scaling and deep dive a bit on that one, like how auto scaling works, what are the best practices, and other details around auto scaling. We have Faisal with us. Faisal will help us to go deep dive and understand around with hands-on demo around it. And this week we'll have two sessions, one which will have focus on auto scaling, and tomorrow we'll have another session in the morning from none other than Rohini. So please do participate in both the sessions. And just want to recall one quick thing before I pass it on to Faisal for today's session. We are almost on the verge to finish our boot camp, as we promised that we'll have AWS certification vouchers and AWS credit for the active participation. So please, still it's not late, do participate, do actively promote it. The results are going to be out very soon. So if you are not participating yet, there's a last golden opportunity for you guys to do that for last this week. So please do it and cash it. Uh, that's all from my side. With that, I'll pass it on to Faisal. Faisal, as you all know, leads the AWS user group Hyderabad, and as well as he has his own startup, which he will give a quick introduction from his side. Faisal, over to you.
Thank you. Thanks a lot, Sanchit. You do sound a little sad today. Is that because the boot camp is coming to an end? You feel a little down. But everyone, I must say that a lot of efforts have been put in by Sanchit to put all of this together. So if you guys can, please give him a big round of applause for everything he's done so far, and hopefully in the next couple of sessions that we have remaining, like he said, we will have like the closing out as well as all of the vouchers. Most of you have been eagerly waiting, so I look forward to that. And I believe this probably would be my last session for the bootcamp, and it's been a good ride so far, and I hope every one of you also liked all of the sessions that we have done. And of course, any feedback that you have, or anybody who hasn't joined the group yet, please do. Thanks a lot, Sanchit.
Thank you.
All right. Do you want to add the screen share, Sanchit? Yep. Thank you. All right, everyone. Thank you for joining into today's session number 12. And today we are going to talk about autoscaling. Let me give a quick introduction about myself. This is me, Faisal Khan. I'm currently a founder and CEO at two organizations. One is Ecom India Cloud IT, which is a cloud-based company, a partner with AWS. We help customers migrate and move on to AWS. Also recently started Excite Logic, which is based in the US. It's a SaaS company. We're just starting something up, so hopefully you'll see something there soon. On the AWS side of things, I currently lead the Hyderabad user group, and also I happen to be an AWS community builders, which involves doing sessions like this and talking more about AWS basically. And on the certification side, recently I did get certified on the solutions architect professional side, as well as the associate. What else do I do? I have a YouTube channel called EICIT Learning, which is more or less around AWS training. So when you get the time, please have a look at it. And recently, I also started out my own brand, which is called Racer Parrot, around Formula One racing. Couple of products are available on Amazon. So if you want to have a look at it, please do. Having said that, let us look at today's topic, which is autoscaling. So before I go into this topic, can anyone tell me what do you think autoscaling basically means on AWS? Like, have you heard about this concept? And what do you think it is? What does it help you do in terms of maintaining your environment? Anybody could quickly give me a quick brief on the chat if any one of you could answer that before we even go into this. I hope there's not a long delay like the last session where I said something and you guys were hearing it after or whatever you typed in, I was getting it after 5-10 minutes. All right, I'll wait for your answers to come through, but I will move on as well a little bit on this. Okay, so it says nickel says it is for maintaining. Yes, Sanjit, could you bring up some of those comments on screen? So I think nickel says it's for maintaining capacity as per demand. And then Rishikesh says that it helps for scaling out and scaling in per request. Yeah, but that scaling out, scaling in, that was a question about, what is that scaling, right? Dorach says it's for monitoring your applications and automatically adjusts capacity. Okay. Automatically scaling resources. But the question is like, what is that scaling, right? That's what the question was. Um, Madhur says systems decide when to expand capacity. Okay. Prasad says scale out. And again, question is, what is that scale, right? And Ramakrishna says to maintain the performance of the application and on demand. Okay, so most of you looks like you know what autoscaling is. So maybe we shouldn't do the session. We should like stop it and go home or something like, because almost all of you know what this is. But we are here today to learn a little bit more in depth. Okay, I think Rushikesh also says compute resource intent scaling, and Rishabh says expand capacity. Kamaraju says scaling instances on demand, and Mohammed says increase instance type or number of EC2s. Okay, so most of you got it right. And we'll look at these details now. So we're going to go a little bit in depth and understand what this actual scaling is. So first of all, auto scaling is about either increasing the footprint of your infrastructure or decreasing the footprint of your infrastructure, right? So let's say that this could be something called as vertical scaling as well as horizontal scaling. All right, so there are different types of scaling that you can think about. Let me just quickly bring up my whiteboard here so that I can just explain this a little bit better. Okay, so there is the concept of vertical scaling as well as horizontal scaling, right? So there are two types of scaling that you can think about. But in AWS, mostly you're going to deal with the horizontal scaling part. So what does it mean? So if you have one instance, for example, one EC2 instance, right? When you're talking about horizontal scaling, you're talking about increasing the number of your EC2 instances, right? Or this also can be about decreasing the number of EC2 instances that you have. This is to make sure that you match the demand or the capacity required at that point in time. Maybe during the peak hour of the day, maybe like 7 p.m., you might need 100 EC2s, but maybe during midnight, like 2 a.m., you might not need that many EC2s. You might only need like 5 or 10, right? So it's basically to scale according to the demand. There is also the concept of vertical scaling, which basically means if you have an EC2, for example, which is, let's say, a C5.x large, right? And when we are talking about vertical scaling, we are talking about increasing the size of the instance itself. So from a C5.x large, you could maybe go to like a C5.4x large, right? So that is vertical scaling. But when you're talking about auto scaling, you don't generally tend to do the vertical part of it because it's always better to have more instances than try to increase capacity on a single instance, right? There are a lot of reasons in terms of redundancy, availability, and all of those kind of scenarios. But scaling is basically the concept of adding or removing resources in order to maintain your environment. Now, why would you want to do this? What benefit does it give you, etc.? We will see. But one of the major benefits that you're going to see with scaling is that you are going to save cost, right? Now, you might ask me, how is adding more instance going to save me cost? We will look at that in a couple of slides. So auto scaling is basically adding or removing EC2 instance with regards to the capacity requirement based on certain metrics. So you don't just randomly add, you base it on certain metrics that you need based on your traffic or based on the CPU, etc. Right? There is no additional charge to using this service. So if you're using the auto scaling service, there is no particular charge for using it. But of course, if you have X number of EC2s that you are putting into this auto scaling group, then obviously you're going to be charged for those EC2s. This will help you minimize your cost as well as maximize your performance at the same time. This also integrates with the elastic load balancer in the sense that if you have a load balancer that is taking traffic coming in from the internet, and then you have these EC2 instances that are behind the load balancer. If you remember in our ELB session or our load balance session, I kind of mentioned the fact that these ELBs constantly do a health check to your EC2 instances, right? So they are always constantly checking the health of your EC2 instances using health checks, etc. So when you integrate your load balancer with the auto scaling service or the auto scaling group, you could call that, what happens here is that if at all one of the instances actually fail for some reason during a health check, um, it can actually get the auto scaling group to launch another instance in place of that failed instance, right? So auto scaling sometimes is not just about scaling up or down, it is also about maybe maintaining capacity, right? So if you have two instances and you always want to have two instances, you can also get autoscaling group to do that, kind of maintain the exact number of instances. This process is known as like fleet management, right? The thing is that if you integrate autoscaling with load balancer, they can kind of both work together in order to make sure that your environment is fully functional. So when autoscaling actually adds a new instance, the autoscaling group will kind of tell the load balancer, I have added this new instance, so why don't you go ahead and start sending traffic to that instance. So that's what we mean when we say that it actually integrates with the load balancer. All right, so let's take an example over here where we're looking at the traffic, the number of users that are coming to a website, example.com. So as you can see here, during the daytimes, you can see that the traffic load is peaking, and then during the nighttime, the traffic is falling down. Again, during daytime, it's increasing, going down, etc. Right? Now, if you were a typical infrastructure person that does not have the capability to set up auto scaling, or you're working in an environment that does not support auto scaling, then what would happen here is that typical rules of infrastructure suggest that you are supposed to always provision for peak. That's the sentence that you will hear quite often. And if you look at this diagram, I think this is the peak, right? So you always provision for the peak. So let's assume that this peak is 150 instances, right? And maybe here you only need like 10 instances at this point in time. So you're always provisioning for peak. Now, when the peak is 150, you're not going to provision exactly 150. You would provision something above that so that it never reaches that peak. So what you tend to do is you tend to provision maybe like 170 servers or something like that, typically, right? So what's going to happen when you do that is essentially all of this part where you don't need instances at these point in times, all of this part is completely wasted capacity, right? So you're essentially having to provision for peak, which in turn is costing you a lot of money because you have provisioned 170 servers, but then sometime during the night time you only need 10 servers, right? So you're wasting a lot of money here. So if I take a closer look at this, let's take a single day's example here, 1 day's example. So if you were provisioning for peak, this is where you would normally provision it. And all of this provision capacity, this much part is completely wasted, right? This is obviously where the auto scaling part comes in, where your auto scaling will also provision for peak, but it will provision for peak at that point in time, right? So if you look, for example, the peak at this point in time is this, at the peak at this point in time is this, the peak at this point in time is this, etc. Right? So during different times of the day, there are different peaks. So what autoscaling will do is it will try to provision above the peak capacity during different times of the day. So instead of having to permanently provision like 170 instances, you would probably have like 15 instances here, 20 instances at this point in time, like 50 instances here, like 90 instances here, and maybe like 150 or whatever. So and then obviously you will also bring down the capacity when you don't need it. So autoscaling is not just about um, you know b- taking your capacity up, but it's also about bringing it down. So this will be your autoscale capacity. Hence, the wastage that you have is quite minimal. Okay, any questions so far on what is the need of auto scaling? Why would you even want to put auto scaling to begin with? Any questions? All right. I just want to say that if any one of you who's just joined in, please make sure that you have hit the live button. Otherwise, you might be seeing from a few minutes behind, so it might not be live for you. So please ensure that you hit the live button if you've just joined in. All right. So let's talk about how this scaling policies work. Okay, so there are different ways you can scale out your environment. Now, one of the typical ways you would do it is what you're seeing on the screen here. Now, you have the traffic that is coming into your environment using your load balancer, and then you have your EC2s that are behind your load balancer. Okay. Now, these EC2s are created from a certain configuration. We will talk about what those configurations are. And these EC2s are obviously being monitored by CloudWatch, right? So, CloudWatch monitors these EC2 metrics. It can also monitor the load balancer metrics. For example, the load balancer has different types of metrics like number of connections coming in, number of active sessions, etc. So it can also monitor the load balancer if required. But in this particular scenario that you're looking at on the screen, we are taking a scenario of where CloudWatch is actually monitoring the EC2 instances, and based on the metrics that are coming from the EC2, it's going to make certain decisions in terms of scaling. So let's say, for example, in CloudWatch, we have created an alarm, and the alarm that we have is 75% CPU capacity. Let me just clear this out. So I've created an alarm in CloudWatch which says that if the CPU percentage goes above 75%, okay, I've created an alarm in CloudWatch. And whenever the CPU for these instances go above 75%, I want to trigger that alarm. Now, you might know already from our previous CloudWatch sessions, when you trigger an alarm in CloudWatch, you can either get it to do certain actions or you can just get notified, right? So you have that choice. You can just get notified that this alarm has exceeded, or you can get that alarm to further go ahead and trigger something else. So in this case, we are getting our alarm to trigger something called an auto scaling policy. Okay. Now, this auto scaling policy is where we define what or how our scaling is going to work, right? So this will define exactly how we are going to go ahead and scale out our environment. Now, what is included in this auto scaling policy? You would obviously, this is your auto scaling group, or I would call this ASG, and you would also have something called ASLC, or again, this is my short hand, but it's essentially, it means auto scaling launch configuration. So can you tell me what all is required in order to launch an instance? Because the question here is that if auto scaling policy is triggered by this CloudWatch alarm, so CloudWatch monitors it, and CloudWatch, when it finds out the CPU has exceeded 75%, it will go ahead and trigger this auto scaling policy. And this auto scaling policy then adds an instance onto the auto scaling group. Okay. And because, like I said, the ELB is interconnected with the, or integrated with the auto scaling group, once the new instance comes online, the load balancer has the ability to send traffic to it, right? But the question here is, when the autoscaling policy adds a new instance into the autoscaling group, how does it know what type of instance to add, what is going to be there in that instance? Like, can I just add a blank instance here, or should this instance be similar to the other instances? It should obviously be similar to the other instances, right? So how do I figure this out? How do I ensure that the EC2 that it is launching has everything inside it? This is where your autoscaling launch configuration comes in. Your autoscaling launch configuration is going to define exactly what instance to launch. So can you all give me some examples of what are the things that you would normally need in order to launch an instance? I'm not talking about autoscaling group here, but anything. Like whenever you want to just launch an instance, can you tell me what are the things that you need to select in order for you to launch that EC2 instance? I'm waiting for your comments. So please put it in the chat. Okay. Nikhil says instance type, and Komraju says AMI, right? So you need to define the AMI, you need to define the instance type, you need to, yeah, you need to say how much storage you need, you need to select the security group. Yeah, Nikhil, OS is basically the AMI, right? So that's there. Right. So yeah, Madhur says machine family, yes, instance type, EBS, storage, yes, OS AMI, yes, and any other software used. Yep, security group. Mohammed says security group, key pair. Yep, you need the key pair. Security group, AMI, instance. Yep. So you need all of these things, right? So normally when you launch an instance, you can go through the wizard and select all of this, but you can't expect autoscaling policy to go and select that on your behalf, right? So what you normally do is you pre-select all of this. You pre-select all of this and you make something called the autoscaling launch configuration. So I will pre-select the AMI I need, I'll pre-select the instance type I need, I'll pre-select the storage, I'll pre-select the security group, I'll pre-select the key pair, and I will put that into a configuration. And this is known as the autoscaling launch configuration. And of course, whenever autoscaling policy wants to create a new instance, it will look at this launch configuration, and whatever is defined as per this launch configuration, it will go ahead and launch that EC2. This is to ensure that your EC2 is exactly the one that matches all of the other EC2s, or it is exactly the one that you need inside the autoscaling group. Any questions here on how this autoscaling policy gets triggered? Now, like I said, this has been the core functionality of how autoscaling works, but there has been recent additions to how autoscaling works, which is kind of a black box setup, which we will talk about a little bit later on. So Nikhil has a question: does this mean that vertical scaling cannot be done? Um, it does not mean that. You could choose to still do vertical scaling, where you can get the auto scaling policy to actually launch different types of launch configurations. So what happens here is you can have different types of launch configurations, and in those different types of launch configurations you can have different instance types, right? So for example, you can create a launch configuration for c5.x large, and then everything else remains the same except that the instance type might be c5.4x large. So you can get auto scaling to trigger it and have additional like instances that are bigger than what is already there. You could do it, but the thing is that you want to maintain consistency, right? You don't want to have one instance that is a c5.4x large and another instance that's a c5.2x large and another instance that is maybe like an m5.4x large or whatever, right? You want to maintain some kind of consistency here because of the fact that they're all part of a group, and you don't want different instances to have different experience, because when a user comes in and hits the load balancer, you can't predict exactly where that user is going to go. Okay, so one user might go here, one user might go here. Now you don't want one user to have a better experience than the other user because the one user ended up on an instance that is larger. Okay, so you don't want to have that. But if you are talking about an environment where you just have one or two instances, and you're always going to maintain that only one or two instances, and you just need to scale them up or down vertically, then you could do that kind of vertical scaling. Okay. But if you want to really do that vertical scaling, you really don't need auto scaling policy here. You can even do that with Lambda functions and things like that. Any other questions here with regards to how the auto scaling gets triggered? Okay, now that we know this, let's go ahead and jump into the autoscaling labs part. We'll go ahead and configure some images that are going to be used for our autoscaling, and we'll create the launch configurations. We'll see the different kinds of autoscaling policies. All right. Okay. To begin with, I already have my core application. So I have an application that I want to scale, and my application is currently configured to run on this instance. So if I go to this instance, let me just quickly switch over. So if I go to this instance and if I just copy the IP address, And if I put it in a browser, this is my application, okay, and I want to scale this application. So at this moment, this application is a pretty simple, straightforward one. It is a web page that displays the IP address of the instance that it is running on. Okay, so if you look at this 172.31.87.236, if I go to that instance, you can see that it is in fact the private IP address of this particular instance. So the job of my application is to show me the private IP address of that instance. So if this were to open up on another instance, it should show the private IP of that instance so that I know that it's actually a different server. So I want to scale out this application. So what I will do first here is I want to do something called fleet management, where, for example, I want to have three instances that are part of my environment, and I want to make sure that it is always three. So let me just quickly explain the concept of fleet management before I go ahead and show you this. So let's say I have three EC2 instances, okay? And all of these EC2 instances are part of an autoscaling group, okay? And of course, I have a load balancer in the picture, etc., right? Now, what I want here, or what I want to do here is basically I want to ensure that I always have these three instances running, okay? Now, how do I do that? I will get Autoscaling to do something called fleet management, which is it will monitor these instances. And if any one of those instances go down for some reason, it will basically replace that with another instance to make sure that I always have three instances. So this is also scaling, if you ask me. It's not scaling up or it's not scaling down, but it is still ensuring that your environment is always in a scaled state, that you're not actually losing your capacity. Okay, so this also ensures that you have the capacity that you need. So this concept, like I mentioned, is called fleet management. So let's first see this concept before we go ahead and do the actual scaling up and scaling down policy. Okay, I think Rushikesh has a question. How should we define how high availability purpose in a launch configuration, or it may work comparing desired capacity of respective AZs? Okay, I'm not sure if I fully understood that question, but I think what you're trying to ask is how are you going to define the HA property or the high availability of where your instances are going to be launched, right? So we will see that because part of your auto scaling. Okay, so yeah, thank you for actually asking that. It reminded me of something that I missed in the explanation. Okay, so there, as I mentioned, there is the auto scaling launch configuration, right, which defines what are you launching. Okay, so this defines the what, as in what is the type of EC2, what is the type of, all of that stuff, right? But there is also a how. Okay, and the how is what you define in the auto scaling group configuration. Okay, so in the autoscaling group configuration, you will define as to which AZs do you launch that into, right? And how many instances you're launching at a time, or how many instances are you removing at a time, or additional things as to how are you going to launch, the process of launching. So the actual launch as to what you're launching is defined in the autoscaling launch configuration, and how you're launching it is going to be defined in the autoscaling group configuration. So we'll see that. I hope that answers your question, Rushikesh. Komaraju, yes, desired state is also kind of what fleet management is. So the concept of desired state and all of this actually came after, that was a later iteration of auto scaling policies. Before it was pretty simple. It was just either you do fleet management or you do scaling, right? But all these kind of wordings are a little bit different. So it's not exactly what you're saying it is, but yes, understandably, that's what they try to mean when they say desired capacity. Okay, I think Madhur has a question. So does this ASG use CloudFormation to spin new machines? Not in this scenario, if I'm not mistaken. But if you were using something like Elastic Beanstalk, yes, in that case, it would be using a CloudFormation. Okay, so Now I need, as part of my launch configuration, I do need an AMI, right? Now, of course, I have the choice of just selecting a random AMI, something like the Amazon Linux machine image, and then actually installing my application on top of that. Because see, if I go to launch instances here, and if I go to Amazon Linux here, and if I select T2 Micro and I go here, so I can do this and I can create my I can install my application while this instance is coming up, right? But I don't want to do this when I am doing auto scaling. Why? Can anyone answer why I don't want to do this? Like, I don't want to take a blank AMI and I don't want to install my application when that AMI is getting, like, when that AMI is getting launched in an auto scaling configuration, right? Why would I not want to do this? Any idea? I mean, you could do this, right? But you definitely don't want to do this. There's a good reason why you shouldn't do this. So my question is, okay, yeah, because of course says that it takes time to create the instance, right? So remember, we have a triggering policy in our CloudWatch alarm of 75% CPU, right? This is our CloudWatch alarm, 75% CPU, right? Now the idea here is to ensure that you have a new instance in place before this 75% goes up to 100% and the instances start crashing. Okay, you want a new instance to come in place in the auto scaling group before all of the other instances exceed 75%, exceed 80%, 85, and go 90%, 100%, and then it completely crashes. Because if that happens, then you're in a much worse situation. Okay, this is also one of the reason you don't want to keep this alarm too close. Like, you don't want to say that CPU above 90%, because the room for going from 90 to 100% is very less. So the time period is very less. So this is also one of the reasons that I don't want to install my software every time the EC2 gets created, because of the fact that sometimes it might take long. It might take 5 minutes. It might take more, right? So what I want to do is I want to bake all of my application configuration into an AMI, right? So I want to create my own AMI which has all of my software already installed on it. So that's what we're going to do first here. Let's actually go ahead and create our AMI. So I already have an instance which has my application. So it's pretty straightforward. If I want to create an AMI, there are two ways I can do this, which is right now I can go to actions, I can go to instance and templates, and I can directly say create an image, right? This would automatically create a snapshot and it would automatically create an image or AMI from that snapshot. Or you could always go to the volume, go to actions, and then you create a snapshot. And then of course, once that snapshot is created, then you can go to that snapshot and then you can say create an image from that snapshot, right? So yeah, you could do this, or you could take the easier route, which is just selecting the instance, actions, image, and create image. So let's do that. And I'm going to call this the golden AMI, right? Because of the fact that all of my other instances will use this AMI. All of the other instances are going to be part of the autoscaling group, right? So that's that. So there is a default there is the default volume with that. That's fine. Tags and snapshots. Yeah, I will say project ASG. Create image. The one thing that I do want to mention here is that when you're taking an image of an instance, for example, you saw that option here, which is when you create an image, you have this option called no reboot. And if you enable this, it will basically take an image without rebooting your instance. Okay. Why do you need to reboot an instance? Ideally, that's the better option because of the fact that it's taking a snapshot. And when you're taking a snapshot, you don't want the data on the disk to change, right? Because from the time the snapshot starts till the time the snapshot ends, you don't want to change data, or the data should be the same. It should be consistent. So normally when you reboot, it stops all writes and reads to the disk, so then you don't have any new information. So that's the reason why you would want to do a reboot when you do the AMI creation, right? But if you're actually taking a snapshot of an instance that cannot be rebooted, like it's in production or whatever and cannot be rebooted, then obviously you should select that option which says no reboot. But then if you do that, you also need to, before you do that, you also need to ensure that you go into the operating system level and type in commands which actually temporarily stops all writes to the volume. Okay, this is especially true if it's the main root volume. For the data volume it can be fine, like you could do that, but for the root volume you need to kind of ensure that there's no writes happening there. Okay, so I think my AMI should be done by now. It's still pending. Okay, while this is coming up, I do want to mention the whole new kind of a setup. When I say new, it's been a couple of years. You have this concept called an EC2 Image Builder, right? Now, what I just showed you is manually creating an AMI. Now, obviously, in your production environments, in your real corporate jobs, you're not going to create AMIs manually all the time. You're going to have updates that are going to get pushed, and then an AMI is going to be created from those updates, right? So, what you would generally want to do is you would then want to use this concept of an EC2 image builder, which, as you can see here, the whole concept here is that you're creating a pipeline wherein it will automatically create AMIs from the updates that you're pushing, right? So you will have a source image, which obviously like a base image onto which it's going to apply the changes that you've made. So you can create a pipeline in this way where it's going to automatically create these images for you based on the changes that you're making, right? So you can schedule the bills separately, but the idea here is that when you do this, you can automate a lot of things, including security patches for your AMIs, right? Because if you were manually going to do it, you essentially have to log into the system that has the main image, and then you have to do like a yum update, or if it's a Windows, you have to do the Windows update in order to get the patches, etc. Or if you're using something like Ansible or other configuration management, you have to push the updates to that and then take an AMI from that. Well, if you use an image builder, you essentially get all of this automated, where you can just attach the patches that you need to attach, additional security configuration, additional firewall configuration, etc., that you can bake into the image before that AMI gets created, right? So do have a look at this if you want to automate the image creation part. Okay, my AMI is available. Okay, so what I can do now is I can go to my launch configurations and I will create a new launch configuration. Now, I just want to say here that when you're creating autoscaling group, you can of course use launch configurations, or you can also use launch templates. It's kind of the same in the sense that launch templates is just selecting a preset defined type of instance, etc., and then you're just launching that. But you get a little bit more control with your launch configurations. So let's create a launch configuration here, and I'm going to call this ASG LC. Okay, autoscaling group launch configuration. I'm going to choose my AMI, and because now that I've created my own AMI, you can see that it's actually showing up here as my golden AMI. So I'll select that and I will choose the instance type. I will say t2.micro. Choose. So this is all these steps that I'm doing right now is the same steps that you would perform if you were to manually launch an instance, right? It's almost literally the same thing. So if you want to request spot instances, you can do that. If you want to attach IAM profiles to the instance, you could do that. I don't want to do detailed monitoring right now. I think a 5-minute monitoring is fine. I don't want an EBS optimized instance. I can leave all of this at the default. However, what I do want to do here is I do want to ensure that my HTTP is actually started. So what I'll do is, a second. Yeah, I just want to make sure that my HTTP service remains started. Okay, because I don't want to launch an AMI where the HTTP service for some reason is not up and running. So I'm just ensuring that I'm passing this command, which also means that if you do have an AMI with all of your software installed on it, but then you need to push one or two small, dynamic information updates to it, right? Like for example, you need to update the latest set of IPs in your environment, or you need to update the endpoint of your configuration, configuration and management software or something like that. You can just push that just like how you would normally do when you create the instance. But here it's just ensuring that the HTTP started. Okay, so now this is an important question here. It's asking about the IP address. You have three options here. Only assign a public IP address to instances launched in a subnet with auto assign public IP, which is kind of the default behavior, or assign a public IP address to every instance, or do not assign a public IP address to any instance. So here's my question. What it's basically asking you is, should you assign a public IP address to these instances, or do you not need a public IP address? Can you tell me, do you need a public IP address for any of these instances? And if you do, what is the reason? So the question is, do you need public IP addresses for the instances that are getting launched in the autoscaling group? If you say a no or yes, I do want you to give me the reason as well as to why do you not need an IP and why do you need an IP. Like we're talking about a public IP. We're not talking about a private IP. So I see a lot of no's and yeses, but then you should please tell me that why are you saying no or why are you saying yes? Okay, so I have two arguments here. For someone who's saying no, he's saying, Nikhil is saying, because there's a load balancer, right? So he's saying you don't need the public IPs because there's a load balancer. True. You don't need a public IP because of the fact that you have a load balancer. Okay, but there is also the other argument that I think Sujit is making, where you need a public IP in order to get patches, right? For that argument, Sujit, I would say that you could actually have a NAT gateway, okay, where it's doesn't have a public IP and it can go out through the internet through the NAT gateway and then get the patches, right? So you could do that if you don't need a public IP. Uh, what are the other arguments here? Autoscaling is not pulling the EC2s. Public IP not required. Okay. Um, so the question here is that, let's say I have an issue with one of these EC2 instances, right? I have an issue with one of these EC2 instances. What if I want to like SSH into that? Do I need a public IP for that? Do I need a public IP in order for me to SSH into any of the systems if there is an issue? Yep. So those are from the previous question. So my question now is, do you need a public IP in order for me to SSH into the instances? Again, if you're saying a no or a yes, I need you to also explain what your position is. Okay, so for a no, Kasukar is saying that you do not need a public IP to SSH into the instance because you can use a Bastion host, which is another EC2 which has a public IP, where you will do something called a jump host, where you will first connect to that EC2. So as a user, you will first connect to that EC2 which has a public IP, and then from that you can private into that EC2 which has an issue, and you can do that. Or of course you can use SSM, which is the latest one. But then you kind of answered my question when you shouldn't have answered it. What I mean by that is, if there is an issue with any of these EC2 instances, why are you even going to log into them? Are you going to log into them? Or give me the reason as to, if you need to log into them, why are you going to log into them if there is an issue with that EC2? Why do you need to log into these instances if there is an issue? Are you going to check the logs? Is that why you're logging in? So when I asked you, do I need a public IP to log into this EC2 instance? Your question to me should have been, why should I log into this EC2? So now I'm asking you, okay, Kasugar says to investigate or collect the logs. But my question here is that, are your logs on these EC2 or is it somewhere else? Because when you have multiple instances, are you going to, like, if you have 100 instances, are you going to log into each of those 100 instances to get your logs? Is that what you're going to do? Or is there some other way you can get your logs? So if you remember, I hope you do, which is when we did the CloudWatch session, I kind of talked about the concept of log aggregation, right? Yep. So Vitul is saying CloudWatch. So CloudWatch has the ability to do log aggregation, right? So you would ship all of your logs into CloudWatch or any other log aggregation system. It doesn't necessarily have to be CloudWatch. There are a lot of third-party CloudWatch as well. There are a lot of third-party logging applications as well. So you would ship all of your logs to CloudWatch and you would have a central location to look at it. But my question here is that, what if it's not logs? What if you want to fix something? So if there is an issue with one of these instances, are you going to fix it or not? This is my final question here. If there is an issue with one of these EC2 instances, are you going to take your time to troubleshoot and fix it? Okay, while you're answering that, I do want to make one point very clear here, that these EC2s, as part of an autoscaling group, are basically disposable instances. Okay, these are disposable instances which are just doing your compute functionality. As part of an autoscaling group, you would never really put your actual data on these EC2s. So there is no concept of pulling out your data from it, or there is no concept of pulling your logs from it because you've already shipped it somewhere else. There is no point of like configuring your application on this, because I'll tell you in a second why. Uh, but these are compute resources which are there just to process the request. Now, if there is a problem with all of these instances, where is the actual problem? If there's a problem with all of these instances, where is the actual problem? Is it on these instances or is it somewhere else? If there is a problem with, I mean, you know that the ELB is working fine, you know CloudWatch is working fine, you know everything is working fine, but for some reason these EC2s are not working, like they're not loading your application or whatever. So where is the actual issue? Yep, Kasukar. So you're right. I will talk about those different types of states in a couple of minutes, because we are yet to define those steps before and after termination. If there is a problem with the application on your EC2s, the problem lies with your AMI. Okay, because there is something wrong that you configured in your AMI, which is why the application on the EC2s are not working. Now, for some reason, let's say that one of these EC2s has malfunctioned. Please don't waste your time trying to troubleshoot what's wrong on it, because all of the other EC2s are working fine, which means there is no software issue, which means your AMI was fine. Okay. Now, if there is a particular problem with that, just terminate that EC2 instance, okay, or remove that EC2 instance from the autoscaling group. Then obviously it will add a new instance in its place, and then you can work up from there. Okay. The idea that I'm trying to put out here is that these instances in the autoscaling group are always replaceable. They're not permanent. They are there as disposable instances. They do their job and they leave once the job is done. So never actually put anything there that needs to permanently stay there. Okay. Use other things, like if you want to store something, use S3 buckets or use EFS for storing files. If you want to put your logs, use CloudWatch. If you want to put your database, obviously you don't put it in your EC2s, do something like RDS or something like that. But there are some scenarios where, for example, it didn't ship all of the logs to CloudWatch for some reason, okay, or something happened. So there are times where you do need to get onto those EC2s, but then again, to answer the question that we initially started with, you do not need a public IP to do that. Okay, so let's switch back to the EC2 console. So what do I select here? Assign public IP, only assign public IP, or do not assign public IP? In this scenario that we are currently dealing with, do I need a public IP address for the EC2 instances? Okay, I'm selecting do not assign public IP addresses because I am not going to log into it for the logs. I already have a load balancer. I'm not storing any data on those EC2 instances. And my application is just a simple one, so I don't really need any public IPs. Okay, let me create a new security group here, and I will leave it to that. I'll create a new security group. And I will put this. Okay, I need to change this later on. I don't get that option here. So for now, I will leave it to, yeah, for now, I leave it to anywhere, but I need to change that. I will also add a rule which says HTTP because my application is a website. I will select an existing key pair, acknowledge, and I create a launch configuration. So I created a launch configuration which is basically telling the autoscaling group what to launch. Now we're going to create the autoscaling group configuration which tells us how to launch it. Okay, so we're going to take that, go to actions, and we're going to create an autoscaling group from that. Now you can either select this over here and go this way, or you can of course go to autoscaling groups, and then you can just create an autoscaling group. In the next page, you will basically um, see the option to select the autoscaling. Sorry, the launch configuration. So just to clarify that question around desired capacity, minimum capacity, and maximum capacity. So there are three things out there. There is a minimum size, which is the minimum size of the environment, maybe one or two or whatever. And there is a desired capacity, which is kind of like that fleet management thing that I said. So if I say my desired capacity is 3 instances, it'll try to ensure that there is always around 3 instances, right? And of course, the maximum size is what you're scaling out to the total size of the group. Okay, so let's actually go back to launch configurations, and let's select that autoscaling group launch configuration, actions, and create autoscaling group. Let me give this a name. Let me just call it ASG demo, which is autoscaling group demo. And here I get to select my launch configuration. So I'm going to select it's already selected, but if you need to change, you can do that. And I'm going to go next. It's asking me what VPC do you want to use. The one thing that you should keep in mind here is that your launch configuration cannot have a security group that's part of a different VPC, and then you cannot select a different VPC here. Okay, so whichever security group that you created for your launch configuration, it has to be within that same VPC. Okay, so I believe I created in the same one. Let me make sure. Okay, this is part of the default C85. Yep, it's part of the default VPC, so that's fine. So here is where you get to define your high availability parameter. So I think someone did have the question about defining the high availability here. So this is where it decides as to which all AZs is it going to be launched into. Now, if I select two AZs, for example, I select 1A and then I also select 1B, you can see that it's actually selected 1A and 1B. Now it does do it in a round robin fashion in terms of adding instances. So it will add the first instance in 1A, second instance in 1B, third instance in 1A, fourth instance in 1B, etc. So it will keep going like that. If you have 5 instances, you might actually end up with 3 instances in 1A and 2 instances in 1B. Okay, so just keep that in mind. And let's go next. So now I can obviously attach a load balancer. Now, just to let you know, I've already created a load balancer. I've already created a target group, etc. Let me just actually show you that. Okay, my current target group actually has the existing instance in it. So let me actually remove that instance. Because once I created an AMI, I no longer kind of need that instance. That I mean, at least temporarily, I don't need that instance, but I'll keep it around if I need to modify the AMI or something. I'm just removing that instance that I already had from the load balancer. Okay, so that I can just add only the new instances to the load balancer. So let me come back here. Let me attach an existing load balancer, and of course, you can create a new load balancer if you need. You have two options. You can select your target groups. If you are using an application load balancer or a network load balancer, you can select your target groups. Of course, if you're using a classic load balancer, you just need to select your classic load balancer. Okay, so let me actually, I already have a network load balancer configured, so I already have a target group that is configured for the network load balancer, so I'll select that. This page is just the load balancer page, guys, nothing specific here. I will also ensure that it uses the load balancer's health check and not just the EC2 health check. Now, there is a health check grace period here, which says that how long should the autoscaling group wait before it does a health check once the instance comes up. Okay, because remember, once the instance comes up, there might be some additional checks that you have in place. For example, it might be installing some additional software, it might be configuring some additional settings or whatever once the instance comes up. So it's not necessary that as soon as the instance comes up that it is going to be live. If that is the case, then you need to give it some time, okay, before it starts doing the health check. Because as soon as it comes up, if you do the head check and if it fails, what's going to happen? It's just going to terminate that instance and then try to bring a new one. And obviously this is going to continue in a cycle because your EC2s just cannot come up and stay on for some reason, right? So you want to manage this grace period carefully. You don't want to keep it too short and you don't want to keep it too long. In my case, my instance is almost instantaneous. It's not doing anything special, but so I'll just give it like 60 seconds grace period. But if your instance is actually having to install something or configure something once it comes up, ensure that you give it a proper amount of time over here. Now I will enable this in CloudWatch because I do want to monitor this in CloudWatch, right? So I will select that next. Okay, I was expecting to see the thing here, but it's not showing here. Okay, let me see. Let me set my desired capacity to 2, for minimum capacity to 2, and maximum capacity to 8. Okay, there are different types of scaling policies like step scaling policy, simple scaling policy, and also something called a target tracking policy. On this screen right now, it's not showing me the other ones. I will have to go back and check once again, and probably I'll try to do that towards the end of the session. But right now, it's only showing me this option, which is the target tracking scaling policy. Let me quickly check if this is available in maybe another region. Give me one quick second, guys. I'm just trying this in another region. I just want to make sure if it's showing up there as well or not. Okay, it doesn't show here as well. Something is missing somewhere. Okay, I think I know. This is yeah. So I'll do one thing. For now, I'm going to select no, and I'm going to come back and later edit this group. So I think yeah, that's how I got it to work the last time. So for some reason they don't show the other policies here. So what I'm going to do now is I'm going to create it without any scaling, but I'll come back here and I will edit it, and that time I should be able to see it, is what I believe. So let me just go next. If you want to get notified when this happens, you could do that, but I don't want to get notified, so I'm just going to go next, next, and I'm going to create this. Okay, let me try to edit this now. Yep, I think, okay, this is the termination. Okay. Okay, I'll check on that. So give me a minute. But right now, I have launched it without any scaling. So what do you think is going to happen when I've launched it like this without any scaling? Is it going to actually scale or not? Because if I go to instances now, you can see that it has launched instances, and it has launched exactly 4 instances because I said that my desired capacity was 4, right? So let's just wait for those instances to come up, and let's wait for it to go behind the load balancer and become active, and let's see what happens. In the meantime, let me look at the questions that you guys have posted. uh, Okay, Kasukar asks, how can we set up auto scaling for a requirement like if CPU utilization goes above 50% for 5 minutes, it should. Yeah, so that was my plan to show you exactly that, because that is called step scaling policy or simple scaling policy. Okay, but it doesn't show that on the console right now for some reason. So I'll have a look at that and I'll try to show that to you later today. Um, yeah, and I think the same question, you have a continuation if it drops below 50% to remove the instances. Yeah, that's what I wanted to show today. Well, let's see. Um, there is, okay, Visual says there's an option below on the page to select if CPU utilization is above 50%. Did I miss that? Are you saying on this page? Because this is target tracking policy. Target tracking policy is different from the policy that I'm looking to show you, which is basically the concept of like simple scaling policy and step scaling policy, right? I'm trying to look for that, but looks like they changed it over here. Yep, let's first see this one and let's see how this works, because I believe this one, if I set it without any scaling, it's basically going to be fleet management, right? So it should essentially ensure that I always have 4. So what I'm going to do now is, once everything comes up, I'm going to delete a couple of instances and let me see if it's actually bringing up new instances in its place. Okay. Okay, I think they're all coming up. I think they should all be fine behind the load balancer. Just give me a second. Okay, let me look at the instances if they are actually active or not. Okay, so all instances are healthy. So what I'll do is I will basically go to my load balancer At this moment, my load balancer is configured with the URL asg.aws-training.in. So let me refresh this and let me see if it's coming up. Okay, so my instances are currently configured behind my load balancer. I want you to watch out for these IP addresses over here. So this one is 86.142. I'm going to refresh. 89.160. 89.160. Let me do a control F5. Okay, the network load balancer works a little bit differently because it has this concept of host affinity. Okay, 86.142. There we go. 86.142. I think you can all also go to this site, guys, asg.aws-training.in. Let me put that in. Okay, 89.160. .142. I'm just waiting for the third and the fourth IP. It looks like I'm just seeing two right now. Okay, so here's what I'm going to do, guys. I'm going to temporarily just use my classic load balancer for this because it doesn't look like it's switching over to all of the instances. So let me actually do that. Okay, if I do that right now, that's also not going to work because it's not in the autoscaling group. Anybody getting any other IPs other than these two? Okay, there we go. 15.70. 15.70. I should not have selected a network load balancer. Should have gone with the classic one. Okay, so far I've got three IPs, which is 86.142, 89.160, and 15.70. I'm yet to get the IP of this for some reason, .55. But I hope you see that it in fact is working right now. All of the instances are behind it. Now what I'm going to do here is I'm going to knock out two instances over here. Okay, I'm going to delete these two instances and I want to see if it's actually going to launch. So I'm going to terminate these two. And before I do this, let me start a stopwatch. Terminate. Let's see how long it takes. So I've now killed two EC2 instances, which basically means how many IPs should I see here? I should not see more than two IPs here. So that's 14.55. Okay, finally that was come through. 14.55. Okay, is anybody getting any IP other than 14.55 and 15.70? Can you confirm on the chat if anybody is getting any IPs? Just put it in the chat only if you are getting a different IP. So 15.70 and 14.55, because right now those are the only two instances that are working here, 14.55 and 15.70. Okay, what we are looking for is we need to see these instances automatically come back up, or new instances come in its place and automatically be added to the load balancer and automatically show up in our application. So right now My application is experiencing some issues in the backend, but in the front end you're not even seeing that, right? As a user, you're not experiencing an issue. The website is working fine because of the fact that it's loading on those other two EC2 instances, right? But we know for a fact that in the backend there has some failures that have happened. There you go, there's one more initializing. There you go. So within about a minute and a half, you see that there is a new instance that got initialized. There should be one more. Now, how soon these new instances come online will completely depend on things like your metrics that you have selected when you launch the autoscaling group, in terms of things like cooling periods, health checks, etc. Because for my load balancer, the health check that I've configured is um, two checks with timeouts of 10 seconds and 30 seconds apart. So your health check on your load balancer is also going to come into the picture of how long it takes for this to come up. Okay, there you go. The second one is also coming up. So do you see what happened? It ensured that it's kind of maintaining my requirement in terms of desired capacity. So I should see these two new IPs come up, 90.183 as well as 89.97. So I'm going to wait for a couple of minutes so that it gets added to the load balancer. So if I go to target groups now, it shows 4 as healthy. Okay, it shows 2 healthy, 4 targets. So these two are still being added to the load balancer right now. Remember, I did not do anything here. All I did was I purposefully went and deleted those EC2s. So think of this like some failure that happened in the backend, and then I am not doing any intervention. I am not coming into the console to start any EC2s. I am not coming into the console to troubleshoot anything. It's all doing it by itself to ensure that my capacity is constant. Any questions in the meantime? Okay, they're still being initialized. It'll actually take a 2 minutes because my health check over here, you can see that it's a 30-second interval and it needs to pass 2 health checks consecutively. So it'll at least take a minute. Okay, it should eventually show up. Let me look at what are the IPs that we are looking for. We are looking for 90.183 as well as 89.97. So 90.183 and 89.97. So I'm going to go here and I'm going to refresh. Even you can check it out, guys. Let me know if you get the new IPs. Still the old 2 servers. So remember, my application is still running. There's no like real impact to my application. Of course, it's down to 2 servers, but it's still running. I should have selected a classic load balancer. This is taking too long. How can we ensure that it's not coming from the cache? Well, there is the possibility that browser cache is there, but then that's why I'm doing a control F5 and not just hitting an F5. And also, I'm not using any other cache mechanism, like I'm not using CloudFront or I'm not using any other sort of caching. So it's unlikely that this is cache. But as you can see, it is anyway switching IPs, which means it is not cache. It's just that the other two instances are yet to kind of be added to the load balancer. So I'm just waiting for that to come online. And if you can see on the top right corner, it's 6 minutes and 24 seconds now. Let me see what is the status of the target groups. Okay, all four are healthy now. So I should essentially see the new IPs here. It's just that the load balancer for the network load balancer, it is not a round robin, guys. So that's the difference here. If you were using the classic load balancer or the application load balancer, it would be a round robin. But the network load balancer uses something, a routing protocol uses something called 5-tuple routing system. So it's not exactly going to immediately route me to the other two. Oh, there you go. So there you go. We have the 18.9.97 and 90.183. There you go. So as you can see here, within about 7 minutes since my application started experiencing a failure, without any intervention whatsoever, my application environment automatically recovered because I had set, I mean, not scaling, but I had set the fleet management as part of the autoscaling group. Any questions here on the fleet management part? So what happened here? Let me just quickly review what happened here. We created a fleet management in the autoscaling group, which basically meant that we had set a desired capacity of 4 instances. So autoscaling group was going to maintain or ensure that there was always 4 instances. Okay. Um, what then happened was I went and deleted 2 instances. So my application front end, although it continued working, like it still was working. Like I, as a user, you don't know that there is something that failed in the backend. But then I did not have to make any intervention. Like I didn't have to go into the console, start anything or anything. It automatically happened. It automatically bought a new instance in its place with the exact configuration that I need, which means the AMI, the security groups, the keys, everything was there. And it automatically also added it to the load balancer because I had integrated the load balancer with the autoscaling group. And then finally it came live. It's just that the network load balancer doesn't do round robin that fast. So that's why you saw it take this much time. But on an average, I have seen this completely happening within under 5 minutes. So sometimes it's like 3.5 to 4 minutes. You can see your environment completely recovered without any intervention from your side. Any questions? Okay, let's talk about the other autoscaling policies. Okay, this has happened quite a bit with a lot of people. When you're done with this autoscaling part, please don't go and try to delete your instances. Okay, because if you do that, what's going to happen? It's just going to launch more instances and keep happening. So when I've had training, like a lot of people, like they come the next day and they tell me that I've been trying to delete these EC2s, but they never go away. That's because you're not supposed to delete these EC2s. You're supposed to go to the actual autoscaling group and delete the autoscaling itself, right? So you could template disable it, but I'm just going to delete it for now. So what then this is going to do, it's going to remove all of the instances that were part of the autoscaling. So you should see it shortly start to delete them. How can I enable static IP address for my application load balancer? So Sujat, I would recommend you go back and check our day 2 session. Sorry, that was I think some session 3 or session 4 where we did discuss load balancers in much more detail. So please have a look at that where we discuss that. Please give me 2 seconds. My power just went out. Let me just make sure that my monitors are back on. Just give me 2 seconds, guys. Okay, apologies for the interruption, guys. We are back. Okay, still deleting that, so it's going to take a few more minutes there. So let's go ahead and create another autoscaling group. Okay, I'm still going to try to see if I can show you the other scaling policies. But for now, what I'll do is I'll just talk specifically about this target tracking policy. So, target tracking policy is a bit of a black box kind of a scaling policy, which basically means you don't really know exactly how it works in the backend. It's based on some AI that AWS uses in order to determine when to scale out and when to scale in. So target tracking policy has a few metrics that it can use to scale. Okay, so it has the average CPU utilization, it has the average network in, network out, as well as the ALB, or the application load balancer request count per target. So, like I said, even the load balancer has some metrics that you can use for scaling. But in this case, let's say that the average CPU utilization is 50%. Okay, so think of this like a band. So let me bring up the oops. So let's say that this is 50%, and then you have your CPU that is going to be kind of like this. Okay, so let's look at this. And when I say the target tracking, what I'm trying to tell AWS is that if I say target tracking at 50% CPU, it's going to take this as a target, right? It's going to take the 50% as a target. And what's going to do, it's going to try to maintain it within that target. Okay. Let's take an example of how much, if you add or remove, how it's going to differentiate. Let's say, for example, you have 10 instances that are currently running. Okay, and let's say that if you these 10 instances are running and they are currently at, let's say, 60% utilization. Okay, now if I add two more instances to this, it might actually fall to 30% utilization. But if I just add maybe one more to this, it will maybe come down to, maybe let's say, 55% or something like that, right? So you see here, which one do you think it's going to choose? It will probably choose adding the one instance, because that averages better to the 50% target. The idea here is that it's going to add or remove instances to bring it as close as possible to your target, right? It's not going to add excessive capacity, because then it will drop below the target. Then it has to again remove in order to bring it closer to the target. Okay, so it will keep on seesawing up and down. So it doesn't want to do that. So it might not always add instances when it goes above 50%, because maybe if it adds it, it'll go much below 50%, and then it has to bring up by removing instances. So the idea here is that it's going to scale up and down based on certain calculations on how many instances it needs to add in order to try to maintain as much as possible with regards to the 50% target that you're suggesting. Again, like I said, this is black box, so you really don't know how it's doing it on the back end. They have some metrics that they have provided, but it's not really something you can make a full guess on. So this is something that you will have to try out for your application to see how it works out for you. So what I'm going to do here is I'm going to put this target value at 50%. Instances need X amount of time before being included in the metric. Again, I'm going to say like 60 seconds. Disable scale in to create only scale out policy, which is if you don't want to bring your instances down, the number of instances, you just want to keep adding, you could do that. Scale in protection is kind of used when you want to launch the newly launched instances. You don't want to get them to immediately be terminated if the capacity drops below a certain percentage. Okay, in our case, we don't really need to worry about that right now, so I'm just going to go next. Again, you can get notified when it scales up or down. Not doing that right now. Go next. And all of that sounds good. Let me create the auto-scaling group. So our desired capacity is 4, minimum capacity is 2, maximum capacity is 8. Okay, so it's supposed to have at least around 4. Okay, and the least it can go to, or it's supposed to maintain around 4, the least it can go to is 2, and the maximum that is going to be part of the group is 8. So let's see if it actually deleted the previous one. Okay, it has deleted all of the previous ones, so I'm just going to make this to running. Okay, so there we have our 4 instances. So let's just wait for this to start showing up here. Okay, here's what I'm going to do as to how to test this. So in our previous scenario, I tested it by deleting a couple of instances to see if it actually automatically scales up, back up or not, like if it brings those instances back up or not. So this one, I'm going to do it a little bit differently. I'm going to use something called Apache JMeter. So let me actually clear out all of this. So I'm going to use Apache JMeter to test out this environment, which basically means I'm going to send a lot of load to the group. Okay. Now I'm not an expert on testing over here, so if I'm making any mistakes in JMeter, please point it out. But what I'm going to do is I'm going to do something pretty simple. I'm just going to make HTTP requests that are going to go to this URL. Okay, so I'm going to make hundreds of thousands of them. Let's first make sure it's all up and running, and then I'll start sending the traffic. And what I want to see is, depending on how much traffic is hitting it, I want to see if it's actually going to scale out or not. So let's wait for these instances to be added to the load balancer. Okay, looks like I missed a couple of questions here. Static IP address for load balancer. Yep. So like Sanchit has mentioned there, it's, if you want a static IP, it's the NLB. And auto scaling available in all regions. Yes, true. It's available in all regions. Any questions while we wait for this to come up? Okay, just one thing I wanted to add here is that don't hit refresh too many times over here, because if you do, each of these is actually API calls, and sometimes it will disable your dashboard view. If you do this too many times, it will say you've exceeded the number of API tries. So just be careful not to hit it too many times. Okay, I think they're coming up. So 93.25 should be, yep, they're coming up. So they should be good. I can start sending traffic to it. Is it just the one? Okay, two are healthy. I should actually change this health check. Just give me a second. Okay, I can't. That's the default. Let me actually change this to 1. Okay, that has to be between 2 and 10. Okay, so I think I'm at the least here. Okay, they're all healthy. We should be good to send some traffic to this. Let me just make sure another IP is loading here. Yep, we should be good. So let's start sending some traffic to it. So what I'm going to do is, this is how I'm going to send the traffic. I'm going to send it in several steps over a 10-minute period. And I'm going to send 10,000 requests. Okay. So by the end of the 10-minute period, there will be 10,000 requests that are hitting the environment. In fact, I want to kill all of those EC2. So I'm gonna like put 20,000 requests. Okay. I think previously it was only 1,000. Okay, so I'm gonna send 20,000 requests. Um, okay, Mohammed says in case of spike in traffic. Yeah, so that's what I'm trying to do here. I'm not going to try to send all of them at one go, because if that happens, there's a possibility that the instance will fail instantaneously, right? So I want the instances to kind of warm up a little bit before it completely fails. So if you see here, um, the first 30 seconds, there will be 1,000 requests. Okay, let me actually put this down to 10,000. Ramp up time over 10 minutes. Do we have 10 minutes left? Okay, we do. Ramp up steps, 20 steps, which means every 30 seconds, 500 requests will get added to the environment. 200 for 1,000. Yeah, I think this should be able to handle it at the beginning. I just don't want it to fail from the very beginning. Okay, so let's see. Any questions or suggestions before I start this test out? Anybody who's good with Apache JMeter, any suggestions you would like to make in terms of sending the traffic before I start this out? Do we have any testers here? I guess not. Okay, let's start this out. Let's hit play. Okay, before I do this, I have to configure my CloudWatch so that I can see all of this, what's happening. So let me go to CloudWatch and let me just quickly create some metrics here so that I can see this. Metrics, auto scaling, group metrics, instances in service, capacity, pending. Yep. Okay, that is for the number of instances in the autoscaling group. Let me add another widget. Let's say metrics, EC2, by autoscaling group. I want to look at the CPU usage. CPU utilization. This is for the entire group, not for the individual instances. Okay, did I actually select the right group? ASG demo. No, I selected the wrong group, sorry. So I need to select the right one. CPU utilization, create widget. I will delete this. I'm just adding some dashboards here so that I can have a look at this. Total instances, in service, and capacity, pending capacity. Okay. Also add another one for the load balancer. So I've added some load balancer metrics as well. Any other metrics that you would like to suggest, that you would like to see while this is happening? Anybody? Yeah, I think that should be good for now. Okay, let me get that started. As you can see here, these are the total number of requests that are going, and there is at the moment 0% error rate, which means the requests are being served, and I can actually see that if I go here. So you see all of these are HTTP requests that are being sent, and if I look at the response, you can see it's basically showing the web page over here, right? So all of these are requests that are hitting the web server right now. And if you look at the summary, still 0% error, which means it's still serving without any issues. Is this visible to you guys? Is it? Because I don't think I can make it any bigger. So I'm going to wait here till it starts showing error percentage, and then I'll start looking at the autoscaling group to see what's going on. So 0.0345, yeah, it's starting to error out, which means instances are starting to fail. Maybe I should not have sent so much traffic, but you see it's failing. 4%, 5% failure, which means instances are starting to fail, which means it was too much too soon, but let's see. All I want to see is if it's actually adding more instances or not. That's why I have forced it to do that. I mean, I could have gradually scaled it and eventually it would have added, but I want to see if it's actually doing that or not. Where is my CloudWatch? Okay, for units. The CPU utilization is going to lag a little bit because I haven't turned on per minute metrics. No new instances yet. So my maximum capacity I had set for was 8 instances, right? So it should essentially give me at least 8 instances once it starts scaling. Yeah, it's almost completely erroring out now. There's no request. If you look at this, almost, yeah, there is maybe one or two in between, but you can see that it's most of them are red. Okay, I'm starting to see a lot more green. Is that because maybe one instance came up? This is the average response time. So you can see it started off at around 3200 milliseconds and looks like it's coming back. Let's see. Any new instances? Nothing yet. Let me remove this running. I hope this demo doesn't turn out to be a complete failure of the auto scaling policy, but let's see. So it's halfway, it's at 5 minutes and 18 seconds. So already sent 6,000 requests out of, there is actually 6,000 concurrent requests right now. What's happening with the target groups? Okay, so you can see there is 2 instances that it has detected has failed. So the connection is draining from those instances. The concept of connection draining is where you're not directly removing the EC2 from the autoscaling group, but instead what you're doing is you're letting the existing connections finish their activity for a certain period, like maybe like 5 minutes or something that you've set in the policy for the load balancer, and then it will remove that after those connections are terminated. I hope my audio is coming through clearly right now. So the question is it going to scale before it ends the test? Because it's at 7.5 minutes. Place your bets, everyone in the chat. Is it going to scale or not scale? Okay, it's down to 2 instances. Okay, it does not look like it might scale before it's over because it's about 19, just under a minute left. Okay, I hope you should be able to hear me clearly now, because what happened was it started sending out all of these packets out, right? And it completely saturated my connection. So I hope that was the reason why it was not clear. Is it still breaking up, everyone, or are you able to hear me okay? All right, great. Okay, looks like the experiment completely failed because it did not scale despite we selecting. Okay, I think the reason it did not scale again was because we had a minimum of two, and because there were two instances that were remaining, is why it did not scale. So I should not have made that mistake, because if you look at this, we finally actually had two instances remaining. So we should have set this to 4, and this as well as 4. Okay, let me just quickly try this once more with a little bit lesser load just for two instances. So hopefully it shouldn't be this bad. Let me just like try 1000 requests. Okay, I'm just going to try this one last time with, we have another 10 minutes remaining, I guess. So no, we're almost out of time, but I'll just try this one last time. So what's happening right now is I have the autoscaling group set to a desired capacity of 2, as well as a minimum capacity of 2. And okay, let me actually modify this to 1, in fact, because otherwise it's not going to scale. Yeah, I need minimum 2. Never mind. Okay. I just want to quickly ask here, were you guys able to see what I was at least attempting to do? Did you understand the concept, which is more important than actually seeing the demo being fully functional? I want to know if you actually understood the concept of what I was trying to achieve in terms of trying to see if it was scaling, because my expectation was that I had kept the auto scaling for target tracking at 50%, which means once the CPU exceeded 50%, it should have scaled out. But because I kept the minimum configuration as 2, only 2 instances had failed out of the 4. So it was at 2, which is probably why it did not scale out. Okay. So let's see if it helps anything right now, because I still have it running right now. I didn't clear the previous one, but let's just wait and see what's happening. Okay, it's got a third instance over here automatically, you see. It's got a third one here. It actually went close to 88 million bytes processed. That's I just sent too much traffic to it. Okay, so you can see that it is in fact scaling out now, because I had set, even though my desired capacity is 2, if I let me just go back and show you the autoscaling group. Even though my desired capacity is 2 and my minimum capacity is 2, you can see that right now there are 3 instances, because I think what's happening here is it is scaling because of the previous event. It's not scaling because of what is happening right now. This is actually a problem that we have seen consistently with a lot of these black box solutions, where these are lagging solutions. These are not exactly a proactive option. So I'm going to try to see, well, probably I can't show it to you today, but let me go back and see what how I can show you that step scaling policy as well as a simple scaling policy. Because in step scaling policy you do get the option wherein you are going to link it to a a CloudWatch alarm, where you create an alarm which says if CPU exceeds 50%. Let me just show you that alarm itself. So if I go to CloudWatch and if I go to alarms, I can create an alarm and I can select the metric, for example, CPU utilization of the autoscaling group metrics. Oh, sorry, I'm looking at the wrong place. Metrics, EC2 instances by autoscaling group, CPU, CPU utilization, select metric. Okay, so here is where I get to make that determination. So if I say average monitoring period of, let's say, 1 minute each, and if I say CPU is greater than or equal to 75%, right? And I can basically create this alarm. So if I go next, I can create this alarm, and I can use this alarm for the scaling actions here. So you can see there is actually a scaling action here. You can select the scaling group, but this is not where you're actually supposed to do it from. It's supposed to show up in the auto scaling group itself. But here's how you do it. You create an alarm for 75%, for 50%, or whatever. And then in step scaling policy, you have an option which says that if this alarm gets triggered, you add these many instances to the auto scaling group, right? And same way, when you scale down, if this alarm hits, for example, let's say 40% CPU utilization, if this alarm hits, remove these many number of instances. Okay, so let me see if I can show that to you once I go back and have a look at it. So what I would suggest you do, guys, is just check back on the same channel. If I do get it, and if I can actually do a demo of that, we will upload a separate video separately, which is not a live session. I'll upload it separately onto the group, onto the AWS user group India group, so you can have a look at it, and probably you should be able to see it. But so far, we have been able to demonstrate the concept of fleet management, as well as we kind of attempted to use the target tracking policy to show how the traffic scales out. But apparently that did not work out as expected. When you're doing the labs, and when you're done with these labs, please ensure that you try to follow these steps as much as possible. Otherwise you will end up leaving something in there that's going to cost you money. I want to thank you all for listening in, and let me hand it over back to Sanjit.
Thanks, Faisal. That was really a wonderful session. Backed by a couple of good demos. I think I know one or two things we were not able to demonstrate, which, as you mentioned, for sure we'll work around in the background and have it ready before our next week session. But yeah, it was really wonderful where we talk about and we understand in detail how things works in terms of auto scaling. So that's what we have from this week. I would request I'll take a pause for a few minutes. If you have any questions, queries, please post in the chat. And just want to quickly give you a reminder, we'll have tomorrow's session at 10:30 in the morning, and we'll have none other than Rohini with us to talk about architecturing best practices, well architect reviews, and other things which you need to consider for solution architect associate. So please do join tomorrow's session. It will be the information is already given of the link, and it will be at 10:30 in the morning. So we'll take a pause. If you have any questions, please post in the chat and we'll happy to answer. I think we are good and there are no questions. So thank you so much for joining. Have a wonderful evening and we'll see you guys tomorrow. Thank you.